Alright, so compound interest is actually how interest rates are calculated in the real world, okay? The way this is done is, in the simple interest, regardless of how much you've paid off or how much the loan is worth, it charges you the same amount every time. With compounding interest, it rescales at every compounding interval. So if you compound monthly, what that does is it says at the end of a month how much money is left on your loan and compounds that amount. So it takes the interest rate from that amount. It's a far more fair system. If you're paying off a loan, that means it's rewarding you for paying your loan off quickly. Vice versa, if you've invested money or someone's borrowed money off you and they're not paying it off quickly, then you get a lot more money a lot more quickly. Are we clear? Because what type of function is that? How's that going to grow? Is that going to grow in a linear way? Exponential. Whereas simple interest is talking about a linear model, where it increases by the same amount every time. Happy with that? So whenever you take a loan, that's what happens. And your principal is that talking about the money you had at the start?
No.
It's the money in the account or the money in the loan at that exact moment in time. Cool? Not an overly difficult equation, very similar to the simple interest. The main difference is that we're now to the power of n, not multiplying by n. But the trick is identifying your interest rate and the number of terms by how frequently your rate's being compounded.
What chapter is this from?
8.2. So whenever you've got a different compound rate, so I'm going to start with an example where we're compounding yearly. Whenever you've got a different compounding, you need to adjust your I and your N accordingly. And the way that you do that is that you divide your interest rate by the amount. So if you've got an interest rate of 12% and it's being compounded monthly, what should your interest rate now become? 1%. And if you've got that loan for 1 year, how many times are you going to compound that? What's your N? 12. Does that make sense? So you divide your interest rate by the amount of days or weeks or fortnights or months or quarters in a year, and you multiply your N by the same amount. Clear? Start you off with a simple one over here. We'll run through this one over here, and then we'll go to an example from question 3. Yep.
Why amount do you like it?
So multiply N by the amount that you've multiplied above, or divided for that one there. So so the amount of fortnights in a year, for example. That's what I mean by N. So how many fortnights in a year? 26. So if I had my interest rate compounding, my amount compounding every fortnight, I would divide my interest rate by 26 and I would multiply my number of years, N, by 26.
So the amounts of terms?
Yep. No, divide your interest rate and multiply your number of terms. Okay? Hopefully this stays up, I bet it doesn't. There we are. Okay, so $3,000 at 13% for 5 years. Very similar to a simple interest. So you need to be very, very careful when you're reading these questions, for example, on an exam, that you are aware of the term simple and compound. If it says simple interest, we would use I equals PIN and A equals P plus I. For the compounding interest, we have A equals P 1 plus I to the power of N. How do I represent my I? As a percentage?
Decimal.
As a decimal. Good. So my A is my final amount. My initial amount is 3,000. 1 plus 0.13 to the power of 5. And we grab our calculators out and we see that is equal to?
If we read that question, how would we know it's compounded?
It would either say a compound interest or it would say compounding yearly. But yeah, that's a fair question.
So we wouldn't get a question to that.
No, it would have to tell you compounding or
5,527.
5,527. Now what I want you to do is compare that to the simple interest. So now tell me the simple interest on that same loan. So that's compound there. I'll put simple below. A equals P plus I, which equals P plus PIN, which equals 3,000 outside of 1 plus 0.13 times 5, which equals what? 4,950. Yep. So as you can see, there's a difference between your compound and your simple interest rate. Happy with that? What I want you to do now is take the same problem but get it compounding monthly. So the same problem compounding monthly.
What was that per annum? For 5
And
years.
it's still over 5 years.
Yep, over 5 years.
So you times 5 by 12.
Yep. So n is no longer that, it's 5 times 12. And that should be
16.
and in the same equation. Yep.
When you put 16 where n is supposed to be, it spits out a massive number. Can you just divide what you got by 68? Like, did you say?
Did you change your interest rate? You need to change your interest rate.
Oh, okay. Oh, the right.
What is 0.13 divided by 12? 0.01.
Yeah, one.
That'll do. You need to put a few decimal places there, but what do we get for that? Thank you. 5,700 and
25. I got 25.
I got 26.
who used more decimal places?
No, I got 5,700.
Oh, 5. It's all about decimal places there. How many did you use?
I just put it in my calculator.
So, and what did you get?
5,700.
Yeah. So, I'm going to guess that we didn't use enough decimal places.
Monthly.
Yep. So, as you can see, does the compound rate impact your result? Okay, the more frequently it's compounded, the more money you need to pay off because you're increasing the amount at more regular intervals.
So if you pay like